Hello YouTube. It's been a while since I've made a video, simply because I haven't really had anything to take apart, which is a bit of a shame, but there we go. So yep, I've made some upgrades. Actually, I've got some new lights, so hopefully the lighting is going to be a bit better and I can continue to make these videos into the winter months. So yeah, let's crack on. This is a RF power amplifier module from a radio transmitter. A military transmitter. I believe it's probably from one of the big Klansman radios. So it's got a nice sign-on warning about beryllium, which is why I'm wearing gloves. So 99% it's just the ceramic on the power valve or transistor or whatever it is that's beryllium oxide, and that isn't going to pose a danger at all unless I try and grind it up and inhale it or something, but there's a very slight chance that the thermal compound also contains beryllium, so yeah, just in case it does. So yeah, what else have we got? It did have a motor on there. Oops, let's zoom out of it so you can see. It did have a motor mounted on here for motorised tuning, but I nicked that for some project. Another one on there, I guess, as well. We've got a little miniature, tiny little BNC plug there. Big flat base, a couple of boxes, and some panels. So yeah, let's take it apart and see what's in it. Okay, so we have a big wheel which rotates. So this will be part of the tuning mechanism. In each of these sections there'll be a whole load of little filters which connect to these little contacts, which will connect through to the main power amplifier section. Seen this before on things like signal generators. So let's have this box off the side. Okay, that's interesting. It's obviously some sort of yeah, still need to play about the lighting, don't I? It's obviously some sort of, I don't know, filtery thing, but no very easy way to get into it without cutting all the wires. Okay, maybe I'll come back to that bit. And that's quite nice. We've got some little inductors by the look of it. 8 microhenries, yeah, all 8 microhenries. Okay. Okay, so here is the main power section. We have a power valve, it looks like, in here. Which is undoubtedly what needed the high voltage. An inductor, a variable capacitor here, which changes with that little motor. Some air-wired stuff down there. What else have we got here? In the back there are the contacts which connected through to this big wheel. Some funny little connectors here. They look like they're custom made. With machined out bits of fiberglass laminate. They've actually been milled out, and these little cross pins here, which look like they've come from some kind of ribbon connector a ribbon cable connector plug or something, and they just crossed over so they kind of slot into each other. I've never seen a connector quite like that before. Rather odd. You'd have thought they could have just bought a connector right instead of machining out that whole part, but apparently not. So nice little fairly standard military PCB here, although no conformal coating actually, slightly surprisingly, although this would have been in a big hermetically sealed unit anyway, so I guess that's maybe not that surprising. Huh, the resistor there looks like it's melted. Yep, and there's a nasty brown stain on the transistor next to it. I think we found the fault. I guess that's why it was cheap on eBay. Yeah, tantalum capacitor, some other capacitors. Not much else to see on that. PCB, some more transistors, some caps, some nice little feed-through capacitors there, which of course will self-destruct as soon as you try and unsolder them to salvage them, because these things always do. Okay, yeah, we just have a little filter in there with it. Capacitor. And some little inductors. Nothing much in that box. And I've just destroyed that inductor. Never mind. So this is quite nice, a solid block of Teflon there with the little grooves in it for the wire to wrap round and make a nice inductor there, and a very nice feed-through capacitor. So there is the main power tube with lots of dubious thermal paste smeared all around it. I'll leave that in for now. I'll take it out last because it's going to make a mess when I do it. Okay, that's quite nice. So here's the module with the rotating tuning drum, which we'll take a look at in a second. And here is the half which it mounted into. So we have all these nice little contacts. They look like silver-plated contacts. A little PCB down in there, and lots of bits of coax going off through to this thing. So let's try to. So these are ceramic. And there we go, one extremely nice variable capacitor. Extremely nice and quite custom by the look of it as well, so probably not a whole lot of use for anything else, but quite nice nonetheless. What else have we got on here? Not a great deal. There's a whole lot of caps on the back of that board, some little SMA type plugs. That is about it. A power resistor down there. Yes, and that valve, of course. Oh, that's nice. So that's a whole collection of filters, and there's some little capacitors there, which don't say the value on them, at least nothing easily recognisable. 510G, 360G, 270G, I guess that's picofarad or something. And some nice big inductors with some Teflon feed-throughs. Very nicely made. Nice little filter casting as well. So this is quite nice. It's not just the gear turning the whole thing, it's got this little wheel which indexes with some slots in the main drum and turns it around pretty quickly. That was a miniature multi-way switch to feed back the position of the drum, no doubt. So here we go, and yes, it's pretty much just a filter. Interestingly, there are some actives. There's some little transistors down here, which I wasn't completely expecting, but there we go. A little variable capacitor thing there, big inductor, some more little inductors. yeah, lots of Teflon standoffs. All very nice construction, lots of silver plated stuff. And yeah, a nice casting to keep the sections separate. I expect they're all going to be like that actually. Just with different values of capacitor and inductor in each section. Does not want to come out. Always one, isn't there? So yeah, pretty much the same, except on this one you have a bigger inductor. I think this screwdriver is nearing the end of its days though. That one, there's a much bigger inductor. So there we go, there's the three modules side by side. Big inductor, smaller and smallest. And apart from that, the circuit is bound to be the same between all of them, just with slightly different values. So yeah, there we go, that's quite nice. What else have we got here? So there might be something mounted behind here actually. Let's take this off and have a look. Yuck. That's quite disgusting. Yeah, so all this goo, I mean it's probably just thermal paste, but it might be beryllium oxide thermal paste instead of just normal thermal paste, and there's actually quite a lot of it in there, so I don't know what these funny little parts are. They look like capacitors, but I don't quite know why some rather boring little capacitors would be mounted with all this thermal paste. Obviously ceramic capacitors, maybe their loss was sufficiently high at the frequencies they were being used at, and they did actually get hot, but yeah, that's all fairly nasty to the point where I'm actually going to screw it back so this goo doesn't escape anymore. Come on, get in there. So that just leaves this beast. And this thing does not want to come out. Oh, that's why it doesn't want to come out. It's soldered in. I assumed it was a socket, but no, it is actually soldered in. Okay, so if you look back here, you can see the base of the base of the valve in there, and these are all the pins, and they're actually soldered to these little points here. So no amount of pulling is going to get the thing out. And I don't see that it goes out the other way either. No, this thing actually needs unsoldering before it will come out, which is a bit of a shame. Not particularly serviceable, that actually. I sort of expected better, because being a valve, that's presumably the least reliable part of the whole thing, although I guess some of the mechanics might be a little worse. Yeah, you can't get it out this way because it's stuck to this back plate, and you can't get it out that way because that bit screws into this thing, and it won't go through. So yeah, a bit of an odd design, that. I guess these things weren't really intended to be field serviceable anyway, so there we go. Right, yeah, so there you go. I hope you found it interesting. Stay tuned, there'll be another couple of teardowns coming soon, and hopefully some more videos on my various 3D printer projects. So yeah, hope you enjoyed it. Come again.